How about like number 9? How we doing with? How'd you guys do with that? Any needs or wants with the homework? Are you sure you're okay?
Me? Oh, I messed up because instead of putting like pi over 2, I did like 1.57.
Okay. I wouldn't say it's a mess up, but try to keep it in terms of pi. So is everybody okay that for number 5, k equals the number in front of x? So the number in front of x for number 5 has to be thought of as 1/2. K equals 1/2. Again, anything in more detail that you want to discuss? Okay. The warm-up. Although I saw some right answers, which is great. That's what I wanted you to do, was to explore this on your own. I find that this isn't a bad thing for you to hear from the teacher. Maybe you're going to hear the same thing. Maybe you're going to be like, oh, I didn't think it that way. But as we move closer to drawing sketches, we want to make sure we're thinking of this the right way. The answers look good. I expect that you'll get these 3 answers. Think about the amplitude with me for a second. The amplitude. It is going to end up being how high and low the graph goes. Not that you had to do this, but sometimes people will sort of make almost like a boundary that's at 3 and -3. Okay, kind of keeps your graph within those 2 y values. Now, I do want to say this. You have to do the shift before you do the period. You have to do the shift before you do the period. And you have to know that the original sine wave would have started at that black point, 0, 0. So what that means is I'm going to take that black point and I'm going to shift it 30 degrees to the right. This is an important point. I'll say nicely, if you didn't label it, you should. It should be part of a nice final answer. And the cool thing about noticing that the graph starts at 30 is that I now can say where it ends, which would be a full period from 30. Now, a full period from 30 is going to be way out there at 390. So again, I'll say, did you label 390? I mean, if you didn't, understand that'd be part of a good answer. Now, you could draw a sine wave right now, but I tend to like to have the point in the middle so I have something to kind of connect the dots. And I'm getting a little technical. If you didn't find this point, I think that you have the ability to find it. It's just going to be halfway between 30 and 390. Halfway between 30 and 390 is 310. And now I have some points that I can basically connect with a sine wave. Make sure that you understand that the graph starts at 30. Make sure you understand that it ends at 390 because that's a full period. And in some of these other points along the way, they're kind of the next level of thinking. Like even this maximum right here. I'm not going to get into it right now, but you could find that maximum and minimum by continuing to kind of think about halfway points. Okay, but that's a good sketch of one period with some labels. How about tangent? Tangent. Okay, it has no amplitude. The period is 180 divided by 2. And then, of course, the shift is not 90, but the shift is 90 divided by 2, 45 to the left. Now, when it comes to tangent, you also want to think about its shift point. I'm talking about the original y-intercept. This black point right here is going to shift 45 degrees to the left. It should be the point that you're labeling. I know it was a little tight in there, but I can label -45, 0. Now, here's something that is always true for tangent, and that is that the asymptotes are going to be equally spaced from that center point. Now, to be equally spaced from that center point would be to think about half of the period. And half of the period, 45 degrees, is going to give us a distance that we can travel from that middle point. Now I'm carefully trying to show you that these purple arrows represent a distance of 45 each way because they are half of the period. And of course, if I have two 45s each way, I have a full period, which lands us on a pair of asymptotes. Now, again, if you didn't do all this, it's all right. I kind of wanted you just to try, and maybe we could talk about this idea about half the period from the middle so that we can land on an asymptote of -90 and then back to 0. And then you can draw your tangent graph. You can draw your tangent. Good. Well, from the formula from yesterday, the formula for the period was 180 over k, and k is this 2 right here in the equation. And then the shift is c over k. So again, we divide by 2 because k equals 2. One more thing about this sketch, and again, I don't want you to be like, yeah, I didn't do that. Maybe you didn't, but you can still learn it and think about it with me. And that is that the period, which is 90, is always going to give us the next spot, like the next asymptote. 90 degrees from that asymptote will get me the next asymptote, which is actually going to be at 90. 90 degrees from this intercept of -45 is going to get me my next. So you can always go like a full period to find the next, the next, and the next. I drew 2 periods, but I wanted you to realize that you can use the period to help go to the next spot, whether it's an asymptote or an intercept. More of this next week. Actually, I'll fill you in that next week on Wednesday, when juniors and seniors have sort of a forced hybrid day, and then underclassmen are to be here, that there's an activity that everyone will do that is basically this, through a certain digital platform that I'll show you. It's kind of neat. It's good practice. And honestly, it's actually what we were going to do Wednesday anyway. So you'll spend some time somewhere basically continuing to work on this idea. Okay.
We're taking the PSAT. How does that?
If you're taking the PSAT, then you're busy doing that from 7:30 to 11:30, and then are you an 11th grader?
Yeah.
You can go home.
And if we can't make it, we don't have a ride.
If you don't have a ride, you're supposed to. You can get picked up, or you still can go through your periods 5, 6, 7, and 8. But again, all students, whatever class grade you're in, I'll tell you on Tuesday that there'll be a little digital thing that you'll do to satisfy this. But it's what we were going to do anyway. All right, so you ready for the next thing? Each day we're adding something, and it's supposed to feel kind of natural. And what we're going to add today is what Owen already did for his homework.
Yeah, it took me like 10 minutes.
It's funny. You might not even have realized that you were doing something new, because it's just the next logical thing to do. That is, we're going to write an equation. Yesterday you went the other direction. Today, I guess you could say you're going backwards, but it might seem like you're going forwards, if you hadn't thought about it. Now, what I'm giving you here is sort of that Mr. Naylor style, where can you figure it out? Can you figure out how to write an equation? Can you take yesterday's lesson and kind of do it backwards? I like that you're trying it. There's a lot of right answers. It's also, and not that I can see in your brain, but I kind of have a hunch you're thinking, oh, shoot, do I divide? Do I multiply? Okay, and we hope to answer that question, and it doesn't have to be like a, oh, shoot, am I doing it the right way? How about the amplitude, Dustin? What'd you do with that 2? Pretty straightforward, right? I mean, that's kind of not much more to say about that. It's just, that's what's true about the amplitude. Now, how do you get 2.4 for that next question mark? Like, do you really know how you did it backwards? How do you get 2.4? Now that is the right math, and don't hear me wrong here. That it's completely right. But I'm gonna kind of press this issue. How did you know to divide that way? You know, how did you know it wasn't 150 divided by 360? And it doesn't have to be necessarily answered by a particular person, but this is kind of my pet peeve here, because I just know as we get closer to the end of this chapter, and you guys do this with an application, we get some pretty cool applications coming that at least one student, but probably more than one, is going to be like, oh man, which way do you divide? Okay, now don't hear me wrong. I'm not saying you got to do it my way, but I am saying that if you take yesterday's formula, which said that the new period is always equal to the original period divided by k, I'd like to say you're guaranteed to do this the right way. You're guaranteed, because you can fill in, for the new period, you can fill in 150. You can solve for k. Now, if you're saying, yeah, Ms. Nail, you're kind of making a big deal out of nothing. I'm just saying, I know that people get confused which way to do this. And if you just plug into the formula, I think we all know, again, what Charlie said there, that is definitely the way to solve that. Okay.
On like a test, would you like K to be a fraction or decimal?
Yeah, I think either one's fine. When it gets time to do word problems and application problems, most of you are going to use decimals. Just so you know, I'm not a picky teacher with that. Now, there are a couple times where like fractions are appropriate, especially when radians, when we're talking about that radian stuff. And I thought you were going to ask on a test, do I have to show all this work? You don't have to show it, but you got to do it right. Okay, so how about this last number? There was a little variation with it. It's 216, the highway that runs between Winterstown and Hanover. Have you been on that highway? 216. How'd you get it?
So I knew that. Anyway, it says 90 degrees to the right.
Okay.
So we know that to find, when we're finding the shift, you take C over K. So if you solve for C and you know that it equals 90, you end up multiplying 90 times your K, and then you get 260.
All right. Now, I like, of course, how you described it, because as I hope you guys get the sense, I want you guys to make sure that you know that you're supposed to multiply. And it's because of this. It's because, like Owen said, you're plugging into it. So now, do you have to show all that? It's up to you. But when the problems get a little trickier, if you go back to the formula, it's fail-safe. At least it should be fail-safe if you plug into it correctly. Now, try a couple, okay? And actually, on the back of your warm-up, there's a number. Did you see it? On the back of your warm-up, there's a number. It's just a handwritten number, but it has to do with this. Why don't you, if you're number 1, do the cosine? If you're number 2, see if you can do this tangent. And if you're number 3, the sine. So group 1, just anything to add to this, a little talking. Who's your spokesperson?
Oh, you mean like the person who wrote it?
Whoever you decided would do a little talking.
Alright, so we did 360 divided by 600. Wait. Yeah. Just 600 for the k values. Then we got 0.6, and then we multiplied 0.6 times 50 to find the 630.
All right, now you're good. And as is often true for students, they kind of, hey, I can do this. And you did it right. Just be careful. K doesn't equal 600, but rather the period equals 600. But again, the math is all correct. Group 2. Who's your talker?
Okay. So we did 180 divided by 45 which is 4. And basically we undid that. We just kind of did the inverse of that for the shift.
Why'd you do the original 180 divided by 4?
Because tangent is different from cosine and sine, because its original period is 180 as opposed to 360.
Good. All good stuff to be careful about. Group 3.
So knowing that the period is 180, we use the equation 360 divided by k and set that equal to 180. And then we found k to be 2. And then using the discovered k along with the rest of the given, we found c to be 360 using the equation 180 equals c to. You just multiply the 180 times 2 to find c.
Well said. It was nice to listen to that. I'm sure you guys agree. And it also kind of, like you said, you discovered K. Here's kind of the bummer. If you discover the wrong K, you're probably going to get the wrong C. So just be careful. But, you're checking homework, stuff like that. You're like, I got the whole thing wrong. Well, one thing kind of leads to the next. So just be careful. All right, before we move on, I just wanted to follow up with that first equation, 3 cosine of 0.6x plus 30. And just continue to help you guys be able to see the amplitude, the period, and the shift by looking at the graph. So here's a cosine graph. It should be pretty easy to see the amplitude. Graph goes as high and low as plus or minus 3. How about the shift, though? Where is 50 degrees to the left? Well, it's not right there. That point's not 50 degrees to the left, and it's not right there. In fact, it's actually where the original y-intercept has shifted. Okay, where did the y-intercept go, or where could it be? And the answer is it's right there. Okay, now remember, the cosine graph, its original y-intercept is up there at 0, 1. And that's why this maximum, this point up here at negative 50, is going to represent that shift. Okay, so we have to be looking at the correct point. The period is going to be, well, point to point. In this case, I'm looking at like a minimum to a minimum. And I just want to confirm to you that that distance right there is definitely 600. Now, I'm not going to make this an exit ticket, but I do want to, I hope it engages you, which is really what I want. I want you to be engaged. It's a really good problem. It's kind of the next level of thinking. I'll let you kind of read it, maybe start thinking about it. Good news is we have enough time here that we don't have to rush through this. So we're trying to write an equation for a tangent, but I pulled a fast one on you here. I'm just telling you where the asymptotes are. Do you think you can come up with the equation? If you get to a point where you think you have the final answer, I'm not saying you have to have it, but if you think you got there, graph it. You know, if you're kind of just hanging out, graph it. Does it actually have the asymptotes and the other things that you were looking for? Now, this is always a little risky, but I still like to do it. Not even knowing what the right answer is, I'm just kind of curious, what did you do first? Are you someone that you don't mind sharing? Because it's not like there's only one thing to do first. I'm just curious, what did you do first? Go ahead. All right. How did you, what'd you get, or how did you get it? Now that is correct. The period's 120. Okay, sometimes students are a little hesitant, can I just sort of add these numbers? Well, in an absolute sense, you're finding the distance between the numbers. So the distance between the asymptotes is definitely the period of 120. What did you do first or next? I mean, again, it might be different, but I'd like to hear from you. Okay. All right. Now, I'm just writing down what you're saying because you're not the only person that was thinking that. And I'm just going to kindly say that we need the shift, but that's not the shift. But I like that you guys are trying to find it. I actually like that you tried to divide something by 2. Just what do you want to add to this? It would be, how'd you get it? Wait, did you say to the left? It's to the right. Now, sorry if that changes what you're about to describe. I didn't want to cut you off, but keep going or stop.
So I got that it was 30 to the right because we know that it's halfway between 120 and 60 because the tangent is equal in both ways.
All right. Now I'm gonna do something that you're doing with your hands, and that is sketch it. But I don't want to stop you, so keep going because you said something about halfway.
So we know that between the asymptotes, where the tangent is graphed is in the midpoint between the asymptotes, which is 60, because the period is 120. And so if we go from just on left to right, we add 60 to negative 30, we end up at 30. And then we know that it's generally, or regularly graphed on the origin, so then it's a shift 30 to the right.
Very good. Okay, so a good use of that idea of half the period, and it was well said that the graph is going to be equally in there at that midpoint. I forget the exact word you used, but I guess we need an equation, right? We're trying to come up with an equation. So can we take this information and can we eventually, I think I have it up here. So I'll have you get 1.5. Again, nice job. It's the shift that gets touchy. And again, the shift is 30, which gives us a C value of 45. That's kind of like where we're headed. I mean, honestly, each day I'm trying to add something to our graphing. So we're in the journey. Take a look at the homework, unless you already did it. But it should be the homework that kind of matches with this lesson.